Okay, welcome to this short video about tan graphs. So looking at this graph here, it looks very different from the sin x and cos x graphs. In order to understand the tan graph, let's first understand what these dotted lines are. These dotted lines are called asymptotes. You draw an asymptote when a function is going to infinity. So tan x goes to infinity at 90, then at 270, then at 450, and so on. So if you were, let's say, drawing the tan graph from 0 to 360, you would draw it something like this. You'd say that there are 90 to 180, 270, and 360. Okay, so this graph would go like that. The problem with the tan graph on a calculator is that the calculator will give you an error. It won't show you infinity. And then it's going to just show you an error on one side. It's not going to show you an error on negative infinity. So this graph is somewhat like this. Then it starts repeating itself. Then it goes here. This is another asymptote. Asymptote's a line where the graph is going to infinity. We've done that in functions before. Okay, and then it starts repeating itself like that as well. So that is the idea of a tan graph. It's again periodic, it's not different. The interpretations are slightly different. So you have a tan bx plus c. So c is against the false axis that we've done before. We'll see that in the next question. It's the horizontal line that where you see the graph turning from. Okay, b is again the number of cycles, but this time the number of cycles from 0 to 180, not from 0 to 360. That was typically 0 to 360. So in 0 to 180, I complete one cycle typically. So tan x has period of 180. So period in this case would be 180 divided by b rather than 360 divided by b as in the case of a sin x or a cos x graph. A has no interpretation. Then if there's no amplitude because there's just infinities, we'll talk about how to calculate a if it's unknown. Okay, let's see a few questions here. This is the first question that I want to show you. It says part of the graph y equals to a tan bx is shown above. The graph passes through the point this. Find the value of a and the value of b and the value of c. Okay, so the first thing that I can spot is there's a false axis at 5. So I know that c is going to be 5. Okay, then let's talk about the number of cycles. B, this is 180. So in 180 it's completing one cycle, so I'm going to say that B is 1. Now for the amplitude, which is a for the value of a, there's no amplitude as such. You use these points that are given to you. You say that the value of y is 8 when the value of x is pi over 4. So a equals to 3. That's one type of question that you can have. The other type of question is where I can ask you to draw a sketch. Let's look at this function. The function f of x is given by this. For x is between 0 and pi, it says state the range of f. So what I'm going to do is I'm going to sketch the graph that's in the next part to find out the range. It's going to be difficult to figure out the range because there are some transformations happening. What I see is that now there is a half cycle from 0 to 180, which means that the graph will go to infinity immediately at 180. Okay, it's no longer going to go at 90, it's going to go only once at infinity, and that's going to give me my cycle. Okay, so what I'm going to do is I'm going to try to draw the graph of this function. Now what I must understand is that even though there are uh, pi over 2 and pi. Okay, I know for a fact that uh, tan pi over 4 gives me 1. So in order to sketch this tan graph, what I'm going to do is I'm going to find a lot of tan values at least I think 4 intervals, or I think I can do it at 2 intervals. What I'm going to do is I'm going to use, say, uh, x as 0 and see where this graph is. So I get 3. So I know that my graph will start at 3. Then I'm going to use pi over 2. So half pi over 2 and see where my graph goes. It says it goes to 1. So I know that the graph is at 1 right now. Let me check if this is at 1 actually. Yeah, it should be at 1. So I have the graph at 1. Then at pi, I know that if I plug in pi, this goes to infinity. So this becomes 3 minus infinity because it's going to give me an error. So this becomes minus infinity. That tells me that the graph has to look something like this. And that is the idea of this graph. This is what this graph will look like. So that's the sketch of the graph. What is the range now? I'm going to say that range is y is less than or equals to 3. It's starting from 3 and going to negative infinity. State the exact value of f of 2 pi over 3. So I'm going to use my calculator to do that. I'm going to tell my calculator that I want to plug in uh, 2 pi over 3 here, and that's going to give me the exact value. To be honest, this is supposed to be done without a calculator, and tan pi over 3 tan 60 is basically root 3. So this is going to be 3 minus 2 root 3. Let me just verify that on my calculator. Okay. And then part 4 says obtain an expression in terms of x for f inverse of x. So I'm going to say that f inverse is easy to calculate. Y equals to 3 minus 2 tan half x. Y 2 tan half x equals to 3 minus y. Half x equals to 3 minus y over 2 and tan inverse. And then this becomes x equals to 2 tan inverse 3 minus y over 2. I think I have my inverse now. It's f inverse of x equals to 2 tan inverse 3 minus x over 2. So that is this type of question. If you have more questions, please make sure to write them in the comments and I'll be happy to solve them for you. Thank you for watching.